Hi, I'm Lauren Carlson, and today I would like to talk to you about permutations and permutation groups. Now, the definition of a permutation is a set S that is a one-to-one mapping of S onto S. So if S contains n elements, we may think of the elements as numbered from 1 to n, and of the permutations pi as a mapping of the set 1, 2, 3, all the way up to n onto the same set. Now, a permutation is a function. So in order to write this function, we use a cycle. Now, a cycle is a permutation pi such that pi of I equals j, pi of j equals k, and so on and so forth until you reach the end of your cycle. And pi of n equals I, so the n goes back to the beginning. A cycle containing one element only, say I, indicates this element remains fixed. Now, how do we write these permutations? So let's use an example. In class, we used two columns such that they were both the set S, and then we use arrows between the elements in order to notate where we wanted the elements to go. So let's say that we want 1 to go to 2, 2 to go to 1, and 3 to go to 3. Now, how would we write that? Well, first we need an open parenthesis to indicate the beginning of our cycle, and then we need a starting place. So let's just say 1 to make life easy. So we need a 1 and then a 2 because 1 goes to 2. Then we start at 2 and we see where 2 goes to. Well, 2 goes to 1, so we write a closed parenthesis in order to indicate that the cycle repeats itself and 2 goes back to 1. So then we're left with 3. Well, 3 goes to itself, so we do an open parenthesis, 3, and then a closed parenthesis in order to indicate that 3 goes back to itself. Now that was a pretty basic permutation, so let's try something a little more complicated, like this guy. Well, first we need to start with an open parenthesis, and then a starting point. So let's pick 1 just to make our lives easy. So as the arrows indicate, 1 goes to 2. So we do open parenthesis, 1, 2. And then we need to start at 2 and figure out where 2 goes to. Well, the arrows indicate that 2 goes to 3. So we put a 3. Now, we need to go to 3, and we need to go over to 4, because 3 goes to 4. And then, if you look at 4, 4 goes to 1. Well, that's where we started. So we put a closed parenthesis to indicate that the permutation goes back to 1. Well, now we have 1 cycle down, so we need to start at the next point. Well, let's try 5, because that seems easy. So 5 goes to itself, so we do open parenthesis, 5, close parenthesis. Now we need somewhere else to start, so we do open parenthesis and then 6. Well, the arrows indicate that 6 goes to 9, so 9 would be next. And then we start at 9, and we see from the arrows that 9 goes to 8, so then we put 8. Then we go back to 8, and the arrows indicate that 8 go to 6. So we are going back to 6. So then we need to close the parenthesis to indicate that our cycle repeats itself. And then we're left with little 7. Well, 7 goes to itself, so we need an open parenthesis, 7, close parenthesis. And now we have our permutation. Now, how do we operate with our permutations? Well, generally we use composition with permutations. So let's note an example. Now we need a starting point. So let's try 1 just because it's simple. So, on the inside permutation, we see that 1 goes to 3. And then on the outside permutation, we need to start at 3, and we see that 3 goes back to 1. So, in this composition, 1 goes to itself. So, open parenthesis, 1, close parenthesis. Now let's try 2. Well, in the inside permutation, 2 goes to 5. And in the outside permutation, 5 goes to 2. So 2 also goes to itself. Now let's start with 3. Now, 3 goes to 4 on the inside permutation, and 4 goes to 3 on the outside permutation, so 3 also goes to itself. Now let's start with 4. So 4 goes to 1 on the inside permutation, and 1 goes to 4, so 4 also goes to itself. Alright, well let's try 5. Well, on the inside permutation, 5 goes to 7, and on the outside permutation, 7 goes to 5, so 5 also goes to itself. This is an interesting trend. Now, let's try 6. Well, 6 on the inside permutation goes to 2, and on the outside permutation, 2 goes to 6. So 6 also goes to itself. Well, we only have 7 left, so let's try 7. Well, on the inside permutation, 7 goes to 6, and on the outside permutation, 6 goes to 7. So 7 also goes to itself. So these two permutations are actually inverses of each other. So therefore, that if when composed with each other, they go back to the identity. So now we know what to do with permutations and how they work. So what else can we do with them? Well, we can make a group out of them. Well, a permutation group is any set of permutations that forms a group. So in order to be a group, as we know, we need to have all of the basic requirements. It needs to be closed, associative, have an identity, and have inverses. Now, there are two types of permutation groups that I would like to talk about today. The first is symmetric groups, and the second is alternating groups. Now, a symmetric group essentially is all of the possible permutations with n elements. Now, the formal definition says that the set S sub n consisting of all the n factorial possible permutations forms a group called a symmetric group on n variables. So what's an example? Well, let's try S sub 3. So there are 3 elements that we have to work with. Well, we have the identity, which is 1, 2, 3. And then we have 1 to 2, and then 3, of course, stays in the same spot. And then 1 to 3, where 2 is fixed. And then 2 to 3, where 1 is fixed. Now we have the ones with all 3 elements in the permutation. So then we have 1, 2, 3, and 1, 3, 2. Now the next kind of group I would like to talk about is an alternating group. Now an alternating group is a group consisting of all the permutations on the subscripts. So basically, the permutation only applies to the subscripts of a set, which carry on the function, the permutation, such that 1 is less than or equal to I, less than j, less than or equal to n, for all x sub I minus x sub j onto itself. An easier way to think about alternating groups is to break everything down into tuples. If it can be broken down into a tuple, then it is part of an alternating group. Now, what exactly is a tuple? Well, a tuple is any permutation such that only 2 elements are, so we say, switched. So, for example, the identity is the composition of 2 tuples, so therefore it would be in the alternating group. Now, what about 1, 3, 2? Well, 1, 3, 2 is in the alternating group because it can be broken down into the tuples 2, 3, and 1, 2. Now, there are a lot of permutations like this, but there are also permutations that do not have tuples, and these would not be in the alternating group. Well, I hope you learned some fun things about permutations. Thank you for watching my presentation. Have a wonderful day.